Here we are, back with some geometry, chapter 3, section 3, proofs with parallel lines. This is basically like yesterday's or our previous lesson, just in reverse. Okay, reverse. So, theorem 3-4 is the corresponding angles converse, or converse, however you like to put the emphasis. Okay, so previously we looked at if two lines are parallel, then the corresponding angles are congruent. Well, the other way around, we can look at it if two lines are cut by a transversal and the two corresponding angles are congruent, then these lines are parallel. So this time we're proving that they're parallel based on their angles. That was theorem 3-5. So looking at this example here, it says find the value of x that makes these two lines parallel. In order for them to be parallel, these two angles have to be congruent. So I have to find a value for x that makes this expression equal to 65. So I'm going to set the two equal and then solve for x. So that gives me 3x is equal to 60, divide by 3, and x is equal to 20. So if x is 20, then these lines are parallel. Alright, theorem 3-6, alternate interior angles converse. If alternate interior angles are congruent, then the lines are parallel. Alternate exterior converse, if two lines are cut by a transversal and the alternate exterior lines are congruent, then the lines are parallel. And finally, consecutive interior angles converse. If two lines are cut by a transversal and the consecutive interior angles are supplementary, then the lines are parallel. Alright, proving alternate interior angles converse. So, to prove that if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel, I would recommend that you always first draw a diagram to make sure you know what we're talking about. Okay, alternate interior angles are congruent. Alright, so that would be 4 and 5 in this diagram. Okay, let's write down what we know. Always start with what you know. We know that 4 and 5 are congruent. Okay, alternate interior angles are congruent. What we want to prove is that G and H are parallel. So we can set up our proof, statements, and reasons. Write down what we're given. Angle 4 is congruent to angle 5. We know that angle 4 is congruent to angle 1 because they're vertical angles. We know that 1 is congruent to angle 5 because of the transitive property. If 4 is congruent to 5 and 4 is congruent to 1, then 1 is congruent to 5. And so, because 1 is congruent to 5, we have corresponding angles, so the lines must be parallel. Alright, here we have another example. To determine are these lines parallel, we know that 1 is congruent to angle 3. So we know that this angle here is congruent to angle 3. How can we prove whether P is congruent to line Q? Okay, well, without knowing that these two lines are parallel, we can't really say anything about 3 and 2 at this point. But we know that these two lines are parallel, R and S, so we can look at 1 and 2. We know that if these two lines are parallel, then angle 1 must be congruent to angle 2 because they are corresponding angles. And we know these two lines are parallel. And then if I know that 1 is congruent to 2, and 1, we know that 1 is congruent to angle 3, we know that was given, then we can state that angle 2 is congruent to angle 3, transitive property. And so, if angle 2 is congruent to angle 3, then the line P must be parallel to line Q because of alternate interior angles. Alternate interior angle converse. Alright, and finally here we have theorem 3.9. That's the transitive property of parallel lines. If two lines are parallel to the same line, then those two lines are parallel to each other. So for example, if P is parallel to Q and R is parallel to Q, then P is parallel to R. Here's an example. The flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. So if we numbered these, stripe 1, stripe 2, stripe 3, like this, we could say that given stripe 1 is parallel to stripe 2. Given. And then we could say stripe 2 is parallel to stripe 3, given, to the directly below, immediately below it. And then we can say stripe 1 is parallel to stripe 3, transitive property of parallel lines. And so on. And that is all there is to it.